You should review the section on the standard normal distribution before beginning this section. In this section, we'll practice a variety of problems computing probabilities for the normal random variable. For each of our problems, we will follow the steps outlined on this slide. First, we'll formulate our problem in terms of x. Second, we'll restate our problem in terms of the corresponding z-values. Next, we'll draw our normal curve and shade in the region under the curve in the area of interest. Fourth, we'll use the standard normal tables to find the indicated area under the normal curve. The area under the curve in the interval of interest is the same as the probability of falling in that interval. Example 1. Tire Zone is trying to determine the number of all-weather tires to order for its November inventory purchase. Demand for these tires is normally distributed with a mean of 18 and a standard deviation of 2. The store manager suggested an order size of 23. What is the probability that November's demand exceeds 23? We first begin by stating our problem in terms of x. For our problem, we are trying to compute the probability that x exceeds 23. We then restate our problem in terms of its corresponding z-scores. The z-score for the value 23 is equal to 23 minus the mean, which is 18, divided by the standard deviation, which is 2. This gives us a z-score of 2.5. So our problem, the probability that x is greater than 23, can be restated as the probability that z is greater than 2.5. Next, we draw this normal curve. We indicate our area of interest or our interval of interest, which is x values that exceed 23, and we shade in the area under this curve in this interval. Now we go to our z-chart and we look up the z-score 2.5 in order to determine the area to the left of the z-score 2.5. According to the table, this area is 0.9938. Since we know that the area under the curve is equal to 1, the shaded area that we are interested is equal to 1 minus 0.9938 or 0.0062. Thus, the probability that the demand exceeds 23 is equal to 0.0062. Example 2. The grades on a statistics midterm exam were normally distributed with a mean of 72 and a standard deviation of 8. A. What proportion of students received a B grade? We are defining a B grade as a grade between 80 and less than 90. B. What is the probability that a randomly selected student receives between a 65 and 85? And C. What proportion of students fail the exam or receive a grade that is less than 60? For part A, we begin by stating our problem in terms of x. We are trying to find the probability that x falls between 80 and 90. Next, we restate this problem in terms of its corresponding z-scores. We compute the z-score for 80 as 80 minus 72, which is the mean, divided by 8, which is our standard deviation, and this gives us a z-score of 1. The z-score for the value 90 is 90 minus 72, our mean value, divided by the standard deviation, which is 8. This gives us a z-score of 2.25. Therefore, our problem can be restated as the probability that z falls between 1 and 2.5. Next, we draw this normal curve, indicate our interval of interest, and shade in the area under the function in this interval. We then go to the z-table to look up the z-score 1 and the z-score 2.5. If you go to your standard normal chart, you'll see that the area to the left of a z-score of 1 is 0.8413, and the area to the left of a z-score of 2.25 is 0.9878. Therefore, the shaded region is the difference between these two areas, or 0.1465. Accordingly, we have determined that 14.65% of students will receive a B grade. Example 2B. Find the probability that X is between 65 and 85. If we compute the z-scores for 65 and 85, we can restate our problem as the probability that z falls between negative 0.88 and 1.63. If we look these two z-scores up on the standard normal table, we'll find that negative 0.88 has an area to the left of it which equals 0.1894, and the z-score 1.63 has an area to the left of it equal to 0.9484. The shaded area that we want is the difference between these two values. For this example, the shaded area is 0.759. Therefore, 75.9% of students received a grade between 65 and 85. Example 2C. Find the probability that X is less than 60. If we compute the z-score for 60 in this problem, we can restate this as the probability that z is less than negative 1.5. If we look up the z-score negative 1.5 on the standard normal table, we will see that negative 1.5 has an area to the left of it which is equal to 0.0668. Therefore, the probability that a student fails the exam, or the probability that X is less than 60, is equal to 0.0668. Now let's get some hands-on practice. The weights of football players on USSU's football team are normally distributed with a mean of 230 and a standard deviation of 20. A. Compute the probability that X exceeds 195 pounds. B. Compute the probability that X is between 235 and 280 pounds. You should pause the video at this time and try to complete these problems. You should have started by stating this problem in terms of x, the probability that x is greater than 195, and restating it in terms of its corresponding z-score. The z-score for 195 is negative 1.75 for this problem. Next, you should have drawn the normal curve for this problem and shaded in our interval of interest on the x-axis and the entire area under the curve in this interval. Next, you should have looked up the z-score negative 1.75 on the standard normal table to find that the area to the left of this z-score is 0.0401. Since the total area under this curve is equal to 1, the shaded area that we want is 1 minus 0.0401 or 0.9599. For part B, you should have started by stating this problem in terms of x and then restating the problem in terms of its corresponding z-scores. The z-score for 235 for this problem is 0.25 and the z-score for 280 is 2.5. Therefore, our problem can be restated as the probability that z is between 0.25 and 2.50. If we go to the normal chart and look up the z-score 0.25, we'll find that the area to the left of the z-score 0.25 is 0.5987. Now if we look up the z-score 2.5, we'll find that the area to the left of this z-score is 0.9938. The shaded region that we want is the difference between these areas. For this problem, that difference is 0.3951. Therefore, the probability that x falls between 235 and 280 pounds is equal to 0.3951.